5, we have to finish this. We have to find all asymptotes when our equations aren't like simple, like they were broken down yesterday, like x minus 2 over x squared plus 4. They were already broken down for us, things like that. We need to be able to solve them when it's in like a quadratic form that needs to be factored. Okay? So when we go to solve these, we want to factor everything first. So how do you factor x squared plus x minus 2? X minus 1, x plus 2, yes. And how do you factor x squared minus x minus 6? Yeah, minus 3 plus 3. Or minus 3 plus 3. Okay. So when I factor those, these are able to cancel out. Okay, we want to eliminate things. We want to cancel things out. So that means if I cancel those out, that means x cannot equal negative 2. Because if I would set x plus 2 equal to 0 and solve, I would get negative 2. So x cannot equal negative 2. So now I have the equation that says x minus 1 over x minus 3. If x cannot equal negative 2, do you think that now I have to find my vertical and horizontal asymptotes off of this? How do I find my vertical and horizontal asymptotes? How do you find the vertical? It's the denominator set equal to 0. So I have x minus 3 equals 0. So x equals 3 is your vertical asymptote. How do you find your horizontal asymptote? Yeah, the two constants over each other. So I look at my x's, I take the two constants over each other, and what do you have? 1. So y equals 1. My horizontal asymptote is 1. And then I can graph that. So it's not going to cross through y equals 1. It's not going to cross through x equals 3. And x equals negative 2 is not a solution. So it's never going to hit there is what it's saying, basically. Okay, so that is one example. How do we do this one? 3x cubed plus 7x squared plus 2. How do you factor that? How would we factor that? Or what would we do to reduce that? Or how can we figure that out? Okay. Is there a way to factor that? Is there something we can do? Okay, let's talk about, if we don't think there's something we can do, then let's talk about how do you find your vertical asymptote? Make the denominator equal to 0. Negative 2x cubed plus 16 equals 0. So negative 2x cubed equals negative 16. X cubed equals 8. Take the cube root of 8, and what do you get? What's the cube root of 8? 2. 2 times 2 times 2 is 8, yes. Okay, that's your vertical. How do you find your horizontal asymptote? The constants, the lead coefficients, right? Over top of each other. So, if I want to find the vertical, I'm going to take that, or the horizontal, I'm taking that and that over top of each other. So 3 over negative 2 equals my y, which is my horizontal asymptote. Now, how do you find the domain? How do you find the domain? It is the x, yes. So your domain is what is your domain? If my domain goes with my vertical asymptote. So if my vertical asymptote is x equals 2, what does that mean about my domain? Except for 2. All real numbers except 2. And these are the 3 things that you're going to be looking for in tonight's homework. Yeah, your vertical asymptote will always tell you what your domain cannot be.
Okay.
Correct. Because it's not going to cross there. So it will always tell you what it cannot be. Okay.
Are we done?
Almost. A utility company burns coal to generate electricity. The cost C in dollars of removing the percent of the smokestack pollutants is given by this formula. C equals, let's see here, 80,000 P over 100 minus P, where 0 is less than P and P are less than or equal to P and P is less than 100 because I can't have a 0 in the denominator spot. Okay? Use a graphing utility to graph this function. I need you guys to do that. My graphing utility has no batteries.
That's card mark. Don't forget your.
I actually think I have a spare one.
Wait, what'd you say was your markers?
It has no batteries.
Ah, that's why you come prepared to class.
That's why you get them Duracell.
Okay, my
That's
calculator
why
was like the battery was halfway done, and I just turned it on today. It's like full.
I know, mine does that sometimes
I
too.
didn't charge it.
Okay, so we are going to put 80,000, use parentheses, say parentheses, 80,000, and then you can put an X in for there, end parentheses, divided by parentheses 100 minus X. When you go to graph this, you might have to change your tables.
I just see a straight line.
Is this the same problem or different?
It's the same problem.
It's just a straight line
You got a straight line down the middle.
on the y-axis.
That means your window needs to be bigger. What is your window set at currently?
It automatically changed.
10, 10, 1, 10, 10, 1.
Okay, yes. You have to for sure change your window.
I didn't change mine, it changed on
I
itself.
do 100, 100, and then like.
I would say your X minimum, remember your X minimum is not going to be less than 0.
Yeah.
Your maximum is going to not be, well, it's not going to be less. 0 is less than or equal to your P. P is less than 100. So we're going to go X minimum at 0. We're going to go X maximum at,
110.
is that what it changed yours to?
No, mine changed to like -7 to 12.
I'm going to go X maximum at 300, and I'm going to count by 25s. And then your Y, no. Your Y has that 80,000 up there, right?
Mm-hmm.
So let's go,
81,000.
let's go, no, let's go to like, let's go to like 1 million.
The minimum or the maximum?
For the maximum, sorry. For the minimum, put 0. For the maximum, let's put, yeah, let's just put 1 million. And let's count by 150 and press graph and see if it, yeah.
There we go.
There we go. So you get like an exponential type graph that goes, okay? When you have graphs that are this large, you want to put them, what? Okay, I'll check it out in a little bit. Do you have your like stat plots or anything else turned on an accident? When you graph this, the reason we're going to graph these on graphing utilities is because they're so large. When you do that, you can also find what's happening. Mine automatically drew in the asymptote. My asymptote is that P equals 100, okay? And it has it drawn in for me because I'm counting by 25s on my x-axis, right? That's how I know, okay? The graph of the function, okay, has a vertical asymptote at P equals 100, which is common sense because we can even check this algebraically by saying 100 minus P equals 0. So you get negative P equals negative 100, and you get P equals 100. That's your vertical asymptote. Okay, that's your vertical asymptote. Now, as for your horizontal asymptote, what should that be? How would we technically figure that out?
Maybe
How do you figure it out when you,
the leading coefficient.
yeah, it's the leading coefficient. The leading coefficient is 80,000. The leading coefficient here is
Negative 1.
-1.
Would be negative.
So it'd be like negative, yeah, so, which makes no sense because we're dealing with efficiency, and we're dealing with percentages, okay? So the graph has an asymptote at P equals 100. Because the current law requires an 85% removal, the current cost to the utility company would be that we plug 85% into the P to solve. So we want to solve for this, we're going to plug 85 into the P. So we do 80,000 times 85, and we divide that by what? 15. And you should get $453,333. Okay. The cost to remove 90% of the pollutants would be what? So they're just going to give you numbers to keep plugging in and finding. So the new law would require the utility companies to spend, once we figure out what 90,000 is, or 90 is when we plug it in, we can then subtract the two from each other to solve this equation. So if I have this, I then have 80,000 times 90 divided by 10 gives you $720,000. I'm subtracting from it the 453,333 to figure out how much more money I have to spend a year because of this new law. So this company is required to spend $266,667 more a year because of a new law that was invented to keep the air more clean. Yeah, rough. Okay, these are the three types of things you're working on in your homework. You're working on finding the asymptotes and the domains of equations that you have to break down, and then you're going to work on some word problems through graphing calculator.